Hello, my name is Hernández, and this is my experiment for my key activity of energy and transformation. We're going to begin. These are the materials I'm using. There's 3 liquids and things for measurements that are specified in my paper. And this is where it's going to happen, and we're about to start. That's about it. I'm going to give a more important introduction further ahead.
The experiment plans to show the progression of water boiling compared to other liquids. Now, the boiling point of a liquid depends on the temperature, atmospheric pressure, and vapor pressure of the liquid. When the atmospheric pressure is equal to the vapor pressure of the liquid, boiling will begin. When boiling occurs, the more energetic molecules change to a gas and they spread out and form bubbles. They rise to the surface and then they enter the atmosphere. It requires energy to change from liquid to gas, and the main point of this experiment is to develop a function of temperature against time to be represented in a graph. The variables that are going to be used in this experiment are already on screen. It's the independent, which is going to be time, the dependent, which is going to be temperature, the control variables, which are going to be the container and the flame, and the constant variables, which were the elevation and the room temperature of the city. Materials that are going to be used are also shown on screen. It's a tea kettle, a stove, and an infrared thermometer. The liquids that were used in this experiment are water, Coca-Cola, and vinegar. For this experiment, I poured half a cup of the liquid into a metal container that has a surface area at the bottom that's estimated to be 254.46 meters squared. The temperature was measured with an infrared thermometer every 30 seconds per minute and then every minute until 5. When the liquid started boiling, I turned off the stove and measured the decrease in temperature. The liquids were utilized after the ending of the experiment, and the kettle was emptied, dried, and cleaned to stop cross-contamination. The measurements were recorded in an Excel spreadsheet, and the experiment was carried out in Jalisco, which has an elevation of 1.566 meters over the sea level and a room temperature of 29 degrees Celsius. And now this is a video that I took when I was carrying out the experiment.
I am going to set the starting temperature. I'm going to measure it 3 times, 3.17, 2.45, 2.44. So it's going to be 2.45. I'm going to add to the Excel spreadsheet, and I'm going to turn this thing on. Okay, I'm going to film the process of the first one because the second and third one are just pretty much the same and the additions are different. I just put half a cup of water and this kettle. I'm gonna put it on in medium heat, but I'm gonna need both hands for it. And then I'm gonna start measuring the temperature with that every 30 seconds. That's about it. Let's go.
Now the results are being shown on screen periodically. Water was the slowest liquid. It took about 2 minutes for it to boil, but it cooled down fairly quickly, but it was still the slowest. Vinegar was the fastest and the radiating heat out of it. It ended boiling at 1 minute with a very high temperature. Coke followed by the second line, which had a lower heat, but it still boiled at 1 minute. And now here we go for the analysis of what happened in this experiment. When every liquid was boiling, we saw this very important characteristic of elements, which is called specific heat. For example, vinegar, which burned the quickest, it did so because it has a higher specific heat than water. Henceforth, it gains heat quicker. The soda, which has different element composition, is mainly based around sugar, which has a higher specific heat than water, but it's still lower than vinegar. This shows a great example of how these elements change heat at different rates. The experiment also showed some characteristics of cooling in elements in which we saw thermal conductivity, and that refers to how easily heat can be removed from an object. The materials used had a similar thermal conductivity, but the vinegar had a higher thermal conductivity, which means that it cools down quicker. The high temperatures also made it the fastest liquid in the experiment to cool. The water had the lowest thermal conductivity out of the three, and that's why it's the slowest one to cool down. And the Coke's components had a similar but higher thermal conductivity than water. This means that the experiment showed an explanation of two physical characteristics of elements. Now, the experiment could have been improved if we had better equipment, like measuring tools, like a complete thermometer, because the actual infrared thermometer had some problems picking up high temperatures.